In the previous video we introduced a couple of definitions. We had these propositions P and proposition Q, and we introduced these three concepts: conjunction, P and Q; disjunction, P or Q, we can say P or Q; and the negation, P and not P. There are many ways to write not P. This can be also written this way, not P. Okay, in this video I'm going to give some quick examples on conjunction, disjunction and negation. Let us say, for instance, 1 is different from 3, and let us say that 7 is a odd number. Okay, so we are going to call this proposition P, and we are going to call this one Q. Okay, so this one will be P and this one will be Q. Okay, P and Q will be the sentence 1 is different from 3 and 7 is odd. P or Q will be 1 is different from 3 or 7 is odd. Right, and let us say, for instance, not Q. That will be the sentence I'm going to write it in its full form. Okay, it is not the case. It's not the case that 7 is odd. Don't jump quickly into conclusions. Okay, that not Q is another number that is not odd, or 7 is not odd. Okay, don't jump quickly into conclusions. Okay, negation can also be very tricky. It's not that easy sometimes. Okay, so this one will be the conjunction, right? This one will be the disjunction, and this one will be the negation. Okay, but we know the value of these propositions, right? We know, for instance, that 1 is not 3, of course. So this is true, right? So true. 1 is not 3, so this is true, right? And 7 is odd. Well, this is true too. So what we have here is a true proposition and a true proposition, right? So since P and Q are true, P and Q is true, and since P is true and Q is true, P or Q is also true. Okay, but since Q, 7 is odd, is true, not Q, it has to be false, right? Okay, so we call this a propositional form. A propositional form is an expression involving finitely many logical symbols and letters, okay, or finitely many logical connective symbols, right? Like this one, or this one, or this one. Okay, that's a propositional form. Okay. Now, these expressions that are single letters, like the ones we used here, P, Q, okay, single letters like P, Q, or are formed correctly from the definitions of connectives, are called well-formed formulae. Formulae, the plural of formula is formulae, but I'm going to use this very popular, wrong but popular expression for formulas. Okay, because in Latin formula and the plural will be formulae, okay? But in day-to-day English we say formulas. Okay, so let me give you an example of well-formed formulas. For instance, if I say P and Q or non-Q, okay, P and Q or not Q, this is a well-formed formula. Okay. Now, if I say P or Q and the negation is here, this is nothing. Okay, or something like not P, not Q. Okay, this is nothing too. Okay, or P, Q. All this are not well formed formulas. So you have to be careful in order to form a well formed formula. Okay, otherwise you'll not get to a logical value.